minus 3 sine 3x. I don't know what's wrong with this recording thing. Plus 3y. So what does that come out to be? And what was y? Y was again 2 sine 3x plus cos 3x. All right, so we have this whole left-hand side thing here. So let's see. I'm going to call sine 3x as 3x as alpha, just for simplicity. So it becomes 18 sine alpha minus 9 cos alpha plus 6 cos alpha minus 3 sine alpha plus 6 sine alpha plus 6 cos alpha. All right, so combining the things with, yes?
So I don't get the thing you did before.
Which one?
आपने like a second derivative find out कर लिया ना उसका. अब
Yeah.
उसके बाद क्या किया है?
उसके बाद what I did was I had the equation this d square y over dx square plus dy over plus dx, this whole thing. So I just put that there, and instead of second derivative I put my answer here, and in the first derivative I put my answer here. I just plug those in there.
And Samin, sir ने 3y नहीं लिखा, sir ने y की पूरी value लिखी instead.
हाँ.
Okay, ठीक है.
Now, obviously, what does it become? So minus 18 sine alpha minus 3 sine alpha. If you notice, this is sine alpha, this is sine alpha, and this is sine alpha. So combining all of them, what do you get? So minus 15 sine alpha, right? Similarly, combining the other ones, which are the cos alpha things. So I get minus 9 cos alpha plus 6 cos alpha plus 3 plus 3 cos alpha. So that is 0. Because minus 9 plus 6 is minus 3, and minus 3 plus 3 is 0. So I get minus 15 sine alpha. So in place of k sine alpha, I just have, so this is basically 15 sine 3x. So in place of k, I have minus 15. Okay?
Yes.
All right, moving on.
Yes, sir.
Permutations combinations. All right, so a 5-digit code is formed using the following characters. You have 5 letters, 6 numbers, and 3 symbols, and you can't repeat any of them. So that is 5 plus 6 plus 3, which is 14, right? So you have no restriction, and you want to choose any 5 of them. Now remember that because there's no repetition, there are 2 ways to do this. One is that you're like, okay, I will use the slot method. So I need 5 digits. So for the first one, I have 14 options. For the second one, I have 13. For the third one, I have 12. For the fourth one, I have 11. And for the last one, I have 10 options. What does it mean by options? Basically, you can choose any of the 14 for the first one. But once you have chosen that, then you can choose any 13. You have just one option left over. Okay. So this is the product. You're going to get 14 times 13 times 12 times 11 times 10. Okay. That's one way. Another way to look at this is that you can simply be like, okay, I can choose 14 out of 5 out of 14. But the problem here is that because it's a code, then these things, the order does matter. So it will be 14p5. Because in a code, the order is all that there is, right? It's not just all about the same symbols. It's about the same symbols in the same order. So that is why our answer is going to be 14p5, or you can simply use a slot method. Any questions on this?
No, sir.
No, sir.
Okay, great. Moving on, the code starts with a symbol followed by 2 letters and 2 numbers. Okay, now one thing that they haven't told us is that you can simply use these. So on the first, again, I'm using the slot symbol here. So here I can only choose from the symbol. So I have 3 options. Here I have 2 numbers that should be there, and the order does matter because it's saying that followed by 2 letters and then 2 numbers. So the next 2 numbers, next 2 slots are for the letters, and the last 2 are for the numbers. So for the next 2, I have 5 options here and 4 options here, and that's it. I have chosen 2 numbers out of 5, and then for these 2, I have to choose 2 numbers out of 6. So 6 options here, 5 options here. So this becomes 3 times 5 times 4, because that's how I choose letters, times 6 times 5, because that's how I choose numbers. That's one way. Another way to look at this is that on the first first slot, I just have one option. So I can be like, okay, 3p1, just choose any one of the three. Times, for the next two, I'm basically picking two numbers out of 5 and the order does matter. So 5p2. Times, for the last two, I'm picking any two numbers out of 6 numbers. So 6p2 again, because the order does matter here. Okay, so 6p2 there. Got it?
Yes.
All right. Next is saying the first two characters are numbers and no other numbers appear in the code. That means for the first two, they have to be numbers, and for the last two, last three, they cannot be numbers. So this is again pretty simple. For the first two, what choice do I have? So I'm again using the slot method. For the first one, I have 6, and for the second one, I have 5, because I have to choose two numbers out of 6. So 6 options for the first one, 5 options for the second one. And then I cannot use any numbers. What does that mean? That means that I can use letters or symbols. So that makes 8 options that I can choose from. So 8, 7, 6. All right. In other words, I can be like, okay, I have to choose two numbers out of 6 where the order does matter, multiplied by, out of the remaining 8, I will just choose 3. Again, the order matters. So 6p2 times 8p3. That or 6 times 5 into 8 times 7 times 6. Both of those methods would work. All right. Find the value of k for which the line this does not meet the curve. That is the key point here, does not meet the curve, which means you solve them simultaneously and b squared minus 4ac is less than 0 because it does not meet. So I solve them simultaneously. Kx plus 3 equals x squared plus 5x plus 12. So I just bring it everything to this side. So x squared plus 5x minus kx plus 12 minus 3 equal to 0. That gives me x squared plus 5 minus kx plus 9 equal to 0. And now I know that they do not meet, so b squared minus 4ac is less than 0. So b squared simply becomes 5 minus k whole squared minus 4 into 1 into 9 less than 0. So 5 minus k whole squared minus 36 less than 0. And now I can simply solve this. So 5 minus k whole squared equal to 36. Not equal to, sorry, less than. Now here, from this moment on, I have to remember that I'm using an inequality. So when you solve an inequality, you don't get an answer right away. You basically get two critical values in this case. So my critical values are going to be 5 minus k whole squared is equal to 36, square root on both sides, and plus and minus it because I'm introducing the square root myself. So that gives me 5 minus k is equal to plus 6, or 5 minus k is equal to minus 6, which leaves me with minus 1, that is equal to k, or k is equal to minus just 11. So I have two options here. Now, when what I'm going to do from here on is, there are two options. One is that I draw the curve. I'm like, okay, I have one number minus 1 and one number 11. Because the curve has k as positive, so basically when this thing expands, I'll get k squared minus 10k plus 25 minus 36, all that, right? So I'll get a curve like this. And when is this thing less than 0? This thing, right? When is that line below the y-axis, the x-axis? When the k is between minus 1 and 11. Remember, this is your values of k. So my curve, it is below the x-axis for this region. So I'll be like, okay, that's my answer. That's one option. The other option is that, okay, I'm going to draw a number line. And I have 11 here, I have minus 1 here. Let me just pick and choose different numbers. So let's suppose from here I pick minus 2. When I put minus 2 in the inequality over here, 5 minus minus 2 is 7. 7 squared is less than 36. That is 49 less than 36. In no situation is that correct. So over here, I don't get an answer. All right, I'll pick a number from this side. Maybe I'll pick 0. So on the left side, I have 5 minus 0 whole squared less than 36. 25 less than 36. Yeah, that is correct. So I'll be like, okay, this is valid. Then I pick a number from here. Maybe I'll pick 20. So 5 minus 20 whole squared less than 36. That gives me 15 squared, which is 225 in no universe I know of is this true. So I'll simply be like that, okay, this is the region where my answer is valid. So I'll be like, okay, minus 11 is less than k less than 11. You see, in both of the cases, I'm getting the same answer, except one requires me to do some working. The other is like, you can just draw the line and be done with it. Okay. So remember that when it says less than, then basically you're looking for the curve side that is below the x-axis. And when it says greater than 0, you're basically looking for the point that is above the x-axis. Okay, so that's the region of space where my inequality is valid and where the line does not meet the curve. All right. Okay. At the point where x is 1 on the curve, the normal has a gradient of 1 by 3. Okay. Find the value of the constant k. So what information do we have? First, we know that x equals to 1 for this curve gives me some value for which if I were to get a gradient for the normal, that will be 1 by 3. All right. So I can use that idea that if gradient of normal is 1 by 3, then the gradient of tangent will be minus 3 by 1. Why? Because it's negative reciprocal. So that's the gradient of tangent. And how do I find gradient of tangent? I simply do derivative of this thing. So I'll find dy by dx. Before that, I'll simplify this. So this is y is equal to k into x plus 1 whole squared. So when you take, oh sorry, minus 2 here because I've brought it upstairs. Now this becomes k times minus 2 x plus 1 power minus 3. Power multiplies and the power minus 1 is there. That's how you usually find the derivative. So it becomes minus 2k over x plus 1 whole cube. At x equals to 1, this thing becomes minus 2k over 2 cube. And this should equal minus 3. Okay, why minus 3? Because the gradient of tangent is minus 3. So k equals, I think it is 12, if I'm not wrong. Yeah, so k is equal to 12. Now they're saying using your value of k, so whatever value you got, that will be valid for this. Find the equation of tangent to the curve at x equals to 2. So we already have k, we already have the gradient. So I'll first find the gradient. So gradient is minus 2 times 12, which is k, over 2 plus 1 cube. Why 2? Because 2 is the value of x. So that is minus 24 over 3 cube, which is 27. So that gives me minus 8 over 9. That's my gradient. You don't have to convert it to decimals. And the next point is that find the equation of line. So for equation of line, I need a point and I need a gradient. For the point, I'll simply be like that, okay, y is equal to 12 over x plus 1 whole squared, because x is 2, so I'll get 3 squared, which is 12 over 9, which is 4 over 3. So I have a point, which is 2 and 4 by 3, and I have the gradient, which is minus 8 by 9. So based on that, I can see, yeah.
So I didn't understand how you got the gradient k points.
Oh, that's because dy by dx is given. We just found it in the last part.
Oh, okay.
Yeah. So I just use y minus y1. Yes.
So mean we put the new value of x in it,
Yeah.
Yeah.
not the old one. तो फिर वो आ गया.
So now I have this. And you'll just simplify this using algebra and you will get your answer. All right.
Yes,
Show
sir.
that this left-hand side is equal to the right-hand side, because the left-hand side is more complicated one. I'll start with that. So 1 plus secant x times tan x. Okay. And then because we have to make the denominator same for both, and I'll just multiply it. So this becomes tan x squared plus 1 plus secant squared x. Why is that? Is that right?
Yes, sir.
Yes, sir.
And that's a classic mistake that students do. Thing is, do you notice this 1 plus secant x over here? This is going to multiply with this, which will give me 1 plus secant x that's already there times 1 plus secant x, that's the new one.
Oh, so it'll be a square plus 2ab square.
Exactly, that whole thing. So tan squared x plus 1 plus 2 secant x plus secant squared x over 1 plus secant x into tan x. And now you have to simplify this. Okay. Now here's the thing.
Sir,
Do we have any identity that relates secant x to tan x? Let's go
yes.
to the beginning. We do actually. This one over here, secant square a is equal to 1 plus tan square a. So there you go. Secant square is 1 plus tan square. In other words, tan square is secant square minus 1. So I'll just do that. So secant square a minus 1 plus 1 plus 2 secant x plus secant squared x over 1 plus secant x tan of x. So this cancels out. I'm left with 2 secant x plus 2 secant squared of x over 1 plus secant x tan x. Now here's the thing. I can take 2 as common, I can take secant as common, right? So 2 secant x common, I'm left with 1 plus secant x over 1 plus secant x tan x. So this 1 plus secant x cancelled out. And I have 2 secant x over tan x. What is tan x? Tan x is nothing but sin x over cos x. And cos x, by the way, I can simply call it secant x because sin x divided by cos x is same as secant x multiplied by sin x. So this secant x, that secant x cancel out. I'm left with 2 over sin x. Got it?
Yes, sir.
Yes, sir.
Good, good. All right, hence solve the equation this. Now, here's the thing. I have the same thing over here, and this is equal to 2 over sin x. So I can simply put that instead of this whole thing, I'll simply be like, okay, 2 over sin x equals 1 plus 3 sin x. So when I cross multiply this, I'll get 2 is equal to sin x plus 3 sin squared x. And now I have a quadratic equation. So 3 sin squared x plus sin x minus 2 is equal to 0. I can simply use a quadratic formula or any of the other methods that we know of to figure this one out. Can we do Milgram breaking for this? I think we can. So 3 sin square x plus 3 sin x minus 2 sin x.
Sir, can we
Minus 2 is equal to 0.
put sin x as y?
We can certainly.
Okay.
So if I take 3 sin x as common, I'll get sin x plus 1. If I take minus 2 as common, so I'll get sin x plus 1 again. That leaves me with sin x plus 1 and 3 sin x minus 2 equal to 0. So sin x equals to minus 1 and sin x equals to 2 by 3. Now, because my range is given, in that range, this won't work because sin x is negative for this region, right? But I can't have that because my range is from 0 to 180. So I'll reject this one. I'll start with this one because according to this, now remember this, senior cat, okay? So simplify, we have simplified. Range, we know that. Quadrant, we know this is the first and second quadrant. Alpha is going to be sine inverse of 2 by 3. Do you have a calculator? What do you get?
$41.8.
41.8. All right. So this is your alpha. So this is 41.8 and that's 41.8. All right, so when you do that, what's your theta? Theta is going to be, or theta or x basically. In this case, we'll call it x. So x is going to be 41.8 and 180 minus 41.8. All right, so whatever that comes out to be. All right. How long is this paper? Wow, 11 questions. All right, so let's start with this one. The cubic equation this has 3 positive integer roots. 2 of the roots are 2 and 4. So we know 2 roots. That means we can say that x minus 2 and x minus 4 are 2 roots. Why minus? Because if you say x equals to 2, then x minus 2 is equal to 0, right? So that's one root. Find the other root. So there's some other root. I'll call it maybe alpha. And the value of each of the integers a and b. Now, another thing, because x cube is just 1, so I don't have to multiply this with the number. If x cube was something else, I will have to multiply with the number to figure that one out. So let me just say that this thing on the left is identical to this thing on the right. Plus bx minus 40. So I'm going to apply FOIL here, you know, first, outer, inner, last. So this becomes x squared minus 6x plus 8. And this is x minus alpha. I do it again. So x cubed minus alpha x squared minus 6x squared plus 6 alpha x plus 8x minus 8 alpha is identical to this whole thing, x cubed plus ax squared plus bx minus 40. Now let me try to compare them. Let me say that I'm going to compare minus 8 alpha with minus 40. So minus 8 alpha is equal to minus 40. That means alpha is equal to 5. Now that I have 5, I'll compare, let's say, I compare things that have x squared with them to the thing that has x squared with it. So on this side, I have minus alpha minus 6, and on the other side, I have a. So minus alpha means minus 5 minus 6 equals to a. So a is equal to minus 11. I found it. Now the third option is that I have to find b, which is basically the things with x here and the thing with x on the other side. So I'll say that, okay, 6 alpha plus 8 equals b, and 6 into alpha is 5, which is 30 plus 8 equals to b, 38 equals to b. And there you go. All right.
Yes, sir.
Good. Now they're saying that they have given us this equation. Given that it has 3 integer roots, only one of which is positive. Interesting. Okay. So I'm going to use what we call RRT or IRT, rational root theorem. That's the one I'm going to use here. Rational root theorem basically says, I know it's not part of the AdMath syllabus, but I've always found it useful. So this number here, minus 40, what are its factors? 1, 2, 4, 8, 5, right? 10, 20, 40. Those are its factors, right? And this number with x cubed, what are its factors? Just 1, right? So divide it. Okay. Now the numbers, the rational root theorem says that the numbers that divide this equation are of this form, plus or minus. That means this equation can be divided by plus 1 or minus 1, or plus 2 or minus 2, or plus 4 or minus 4, or plus 5 or minus 5, or plus 8 or minus 8. You get the idea, right? Now that means I'll just try which one works. So I'm just going to try it on the left hand side. I'll use what we call remainder factor theorem. You know about it, right? So I'm going to put x equal to 1 in there. So let me say that this is f of x. So if I put f of 1, what will I get? 1 minus 5 minus 46 minus 40. No way that is 0. Not going to use it. Let me do it for minus 1. Minus 1 cube is minus 1. Minus 1 squared is minus 1. So that's minus sorry, minus 1 squared is 1, so that's 5. And then this one is minus 46 times 1 minus 1, that's plus
Plus.
46. And yeah, this is 0, right? So that means I found one root, okay, which is minus 1. All right, so that's good enough for me to start. I will not go on, although I can simply plug 2 and minus 2 or 4 and minus 4 and 5 and minus 5, and I will get my answer. But that's going to take a lot of time. I have a much simpler method which is called synthetic division. Synthetic division basically says that if you have 1, minus 5, minus 46 and minus 40 here, you can divide it all by minus 1. So I put minus 1 here, I'll get 1. I move this thing here, I get 1. Minus 1 times 1 is minus 1, so that gives me minus 6. Minus 1 times minus 6 is plus 6, that gives me plus 6 here. So minus 46 plus 6 is minus 40, and minus 40 plus multiplied by 1 is 0, which is my remainder. Remember, in synthetic division, this is your remainder, and that whole thing is your quotient. And if the remainder is 0, the thing is a factor. So now I can say that my equation is basically x equals to minus 1, and the second side is x squared minus 6x minus 40 is equal to 0. So if I combine it all, I will say that, okay, one answer is x equals to minus 1, the other is this one. Can you do factorization for minus 40? If we do factorization for minus 40, what do we get? 10 and 6, right? But 10 and 6 don't multiply to give minus 40. Oh, 10 and 4 do. All right, so plus 4x minus 10x minus 40 equal to 0. So I'll get x plus 4 and x minus 10 equal to 0. So I'm getting two answers, x minus 4 and x equals to 10. Okay, so I have found all three roots. Got it?
Yes, sir.
Yes.
Yeah. If you don't know synthetic division, that's perfectly fine. You can do long division, but that's not required in your syllabus. So you can simply go with synthetic division. Now, it is possible to do synthetic division for something with powers of 2 or powers of 3 or powers of 4. I mean, when you have x squared is equal to 1 or something, it is also possible to do it like that, but that's way beyond your syllabus. I don't think it's even taught in A levels. So we don't have to go there. Right, so let's just keep things simple. All right, a particle A travels with the speed this is, oh, vectors. Are vectors in your syllabus?
Yes, sir.
They are, right? Yeah.
But sir, we
Okay.
haven't done vectors, right?
Okay, we can do them then. We'll do them in some other class and we'll leave this question out.
Okay.
Yeah. This question, the diagram shows the points this, midpoint this. We have done this chapter to death, honestly. So you
Sir,
still
I
want me
love
to
this
go through it?
chapter.
It's really
Yeah.
easy, yeah. Yeah,
This
it's
is the
very
chapter
intuitive.
that makes me pass.
Yeah,
Okay.
same.
So do you want me to go through this question or not?
Yes, please.
All right. The diagram shows the points A and B. We know those points. AB is midpoint is M. Okay, so it's easy to figure out what M is. The line PM is perpendicular to AB. So there's this 90-degree angle there. The point P has RS, could be any point. Find the equation of the line PM in the form this. All right, so no worries here. We have to find equation of normal, which passes through the midpoint. Basically, we're trying to find the equation of perpendicular bisector. So let's find a point on the line. Remember, for any line, we need the gradient, and we also need the point. So for this one, let's try to figure out the midpoint first. So M is going to be 5 minus 3 over 2 and minus 1 plus 5 over 2. Midpoint basically. So this becomes 1 and this becomes 2. So that's my point M. And then I have to figure out the gradient. So what's the gradient of AB? That is going to be 5 minus minus 1 over minus 3 minus 5. So that's going to be 6 over minus 8, which is minus 3 by 4. All right. Next, we have to find the gradient of the perpendicular line. And for perpendicular lines, we know that it's basically the perpendicular line will obviously be the negative reciprocal. That's the gradient. So gradient of PM is going to be flip this thing 4/3 and then change the sign. So that's positive now. So that's the gradient. So we have the gradient, we have the line. So y minus y1, which is 2, is equal to m x minus x1, which is this. All right. Next question is actually really easy. They're asking us to find expression for s in terms of r. What is s? S is the y value and r is the x value. So I'll simply put that in there. So s equals s minus 2 is equal to 4/3 r minus 1. And I'll simplify this, obviously. And that's how I get my answer. So pretty straightforward. Okay. All right. Given that the length of PM is 10 units, find the value of R and of S. Okay, 10 units. All right. So there are two ways that I'm going to do this. One method is that I'm like, okay, I don't know what R and S are, but I do know that this point M and that point R, P, the distance is 10. Now I know what M is. It is 1 and 2. And if you look at it, it's going to form a right angle triangle like that. This R and S, what is this length? This length is going to be S minus 2. And what is this length? This length is going to be R minus 1. So I can apply Pythagoras theorem here that, okay, R minus 1 whole squared plus S minus 2 whole squared is equal to 10 squared. Or in other words, I'm basically applying the distance formula.
Wait, sir, but how do you know R is like -1 and S is like -2? How do you get
It's really
that?
simple. It's really simple. If I say that, okay, this point is 1 on the x-axis and this point is R on the x-axis, what's the difference? R minus 1, right? Similarly, if this is 2 on the y-axis and that point is S on the y-axis, so what's this distance? S minus 2, right?
Oh, okay.
Yeah, so we just made a right angle triangle. So R minus 1 plus S minus 2, that's one equation. And the other equation is this one. We have two simultaneous equations now. One is this, the Pythagoras theorem one or the distance formula one. And the other is this. You solve them simultaneously and you'll get it. Now, just to tell you guys, this method will not be valid there. But here's my hunch. Right angle triangles sometimes have what we call Pythagorean triples. So this is 5, then this will be 3, and this will be 4, right? So
Yes.
yeah, so if I double this whole thing, this becomes 8, this becomes 6, this becomes 10, right? So my hunch is that S minus 2 is 8 and R minus 1 is 6. Obviously, this method is just so you can check on your own after you've gotten the answer. This is what I think it should be. It can be something else. Certainly, it can be something else. Not going to be like, no, that's only possibility. It's not the only possibility, but that's just one possibility that I can think of. Okay. So, yeah. All right, y is ln x over x squared. We can simply divide this into u over v. U is ln x and v is x squared. U prime is going to be 1 over x and v prime is going to be 2x. So now I'm going to apply the dy by dx is going to be v squared into vu prime minus uv prime. So when I do that, vu prime is x squared into 1 over x minus ln x into 2x over x squared, v squared basically, okay? So this gives me x minus 2x ln x over x power 4. I can take x as common, so that gives me 1 minus 2 ln x over x cube, and that's my answer. Now they're saying find the coordinates of stationary point on the curve. Remember, this is not for the derivatives. It's basically for this line, which means the derivative of this line is 0. So 1 minus 2 ln x over x cube is 0. So this whole thing goes there, becomes 0. 1 minus 2 ln x is 0, which means 1 by 2 equals ln x. What is the value of x? I take e to the power here. So e power half is equal to x. And there you go. All right, so that's my answer. That is the stationary point where the derivative is 0. All right. Using an answer to part 1, find integral of ln x over x cube. Do I have ln x over x cube? I actually do. Do you see this thing? Ln x over x cube, I already have that there, which basically means that I have, let me break it down. So 1 over x cube minus 2 ln x over x cube. Okay. What is this telling me? This is telling me that if I take integration of this thing, then I will end up with ln x over x squared. Okay. Plus ce, obviously. That's what it is telling me. Okay.
Yes, sir.
So I can use this. I can be like, okay, 1 over x cube integral minus 2 integral ln x over x cube dx is equal to ln x over x squared plus c, which means I can simply be like, okay, what's the integral of this thing? Let me make this the subject. So this thing, integral is going to be x power minus 3 यहाँ पे है, तो it's going to be x power minus 2 over divided by the power, this is minus 2, so minus 1 over 2, minus 2 integral ln x over x cube dx equal to ln x over x squared plus c. So integral ln x over x cube dx equals ln x over x squared plus 1 over 2x squared whole thing. This is minus 2 ना, तो ये minus 2 इधर आके 1 over minus 2 कर देगा. And that's my answer. मुझे c की भी जरूरत नहीं है as such. ठीक है, but if you want to, you can put it there. तो ये my answer. देखिए मैंने, it's a very interesting question कि आप यहाँ से start ही नहीं कर रहे, यहाँ पे आप end कर रहे हो, आप start यहाँ से कर रहे हो. And we are using the idea that integration is anti-derivative. तो derivative हमारे पास है, we work our way backwards to find the integral. Okay, so this was an interesting question. All right, hence evaluate this whole thing. So you just have to apply the limits over this thing. All right, so just ignore the c, apply the limits in this whole thing, and you will get your answer. Do not attempt to integrate ln x over x cube yourself. There is a way. I'm not saying it's not possible. There is a very simple way to do this. We call that integration by parts, and we study that in A levels. So don't worry about it. All right, last question. Solve the quadratic equation without using a calculator. Give me an answer in the form this. Okay, A, B, C. All right, so let me just do it. I'm going to apply a quadratic formula here. So x equals to minus b plus minus square root b square minus 4ac, the whole thing over 2a. So it's going to be a little ugly, but that's fine. Minus 3 plus minus square root b square, which is 9, minus 4a, which is square root 5 minus 3, into c, which is square root 5 plus 3, over 2a, which is 2 into square root 5 minus 3. And now on, it's just a test of our nerves. So 9 minus 4, square root 5 minus 3, a minus b, a plus b, that is a square, which is square root 5 square, which is 5, minus b square, which is 3 square, which is 9, over 2 into this whole thing. I'm not opening the brackets here. I don't need to. This gives me minus 3 plus and minus square root 9 plus 16 over 2 square root 5 minus 3. So that gives me minus 3 plus minus 5. Why? Because 9 plus 16 is 25. Square root of 25 is 5 into 2 over square root 5 minus 3. I'm going to rationalize this now. So into square root 5 minus 3 over square root 5 minus 3. And then I change the sign here. So that's how I get it. And now I'm just going to solve this. So this becomes minus 3 square root. So it's simply minus 3 plus minus 5 into square root 5 plus 3 over 2 into what? Minus 4. Yeah, square root 5 square minus 3 square minus 4. So my answer is basically minus 3 plus minus 5 into square root 5 plus 3 whole over minus 8. Now the examiner wanted us to give the answer in this form. So now you
Yeah,
simply,
but how is it 4? Is my question.
how's it 4? Okay, so a square minus b square. A is this minus 3 squared. So this cancels out. 5 minus 9 is minus 4.
Oh, okay.
Yeah, and then obviously you'll open this up. You will have two options. One is minus 3 plus 5 multiplied by square root 5 plus 3, and the other over minus 8. And the other one is minus 3 minus 5 into square root 5 plus 3 over minus 8. Obviously, this one will lead to 2 over minus 8 times this whole thing. And this one will be minus 8 over minus 8 into this whole thing. So that gives me with a lot of easy options. So minus 3 by 4 plus, minus 1 by 4 square root 5, 4. And this one is just square root 5 plus 3. Yeah. Okay.
So it doesn't match the answer in the question.
Of
The
course.
first one does.
Both of them do. You just needed
Sure.
them in the form of square root 5. You have them in square root 5. Both of them.
Okay.
Yeah. In the first one, A is minus 3 by 4 and B is minus 1 by 4. In the second one, A is 3 and B is plus 1. So we have solved this question. Good work, you guys.